Hello, Chemistry 100L, and welcome to this week's experiment. We are exploring physical and chemical changes. There are a lot of tasks for this week's experiment because you're going to explore a lot of different things. You are going to mix some chemicals together, you're going to look at some colors, you're going to light some stuff on fire, and you're going to explore all those physical and chemical changes. So here's our lab protocol, and here's our data tables. All right. So first thing is to go through and make sure you have everything. Now there's a lot that you're going to need. You will need stuff from the materials kit for this particular experiment, from the equipment kit, from chemical kit number 1 and chemical kit number 2, and then a few things that you should have around your house. So your materials kit, you should have a bag that is labeled Exploring Physical and Chemical Changes. In that bag, you will find your sodium carbonate, a nail, a little aluminum pan, and sodium polyacrylate. Okay, so those are the items in your kit for this particular experiment. Okay, for everything else, what you will need is your test tube rack and your test tubes. You'll want your thermometer, your candle, your forceps, 2 of your large plastic cups, 2 of your small plastic cups, your balance, your ruler, a 250 ml beaker, 5 of your plastic weigh boats, your blue and yellow food coloring, and then you also want your, from your chemical set number 2, you're actually going to want the whole thing. You want the hydrochloric acid, the copper 2 sulfate, the sodium hydroxide, the phenolphthalein, and the magnesium ribbon. Okay? And then from around the house, you are going to need some purified water. It says room temperature, so if you buy water from the store, like this jug that I have, as long as you don't throw it in your fridge and it just sits out, that's perfect. Okay, and then we end up needing sugar and salt for various different experiments. So I've put some sugar and salt in some labeled containers here, and I leave these with all of my lab stuff, and that's the sugar and salt that I have available for my lab work. It says small ice cubes, so I don't have the smallest ice cubes in my freezer. You're going to be doing something with heat with the ice cube, and so the bigger the piece of ice, the longer it will take. So if you have bigger ice like I do, what you can do is you can put your ice in a plastic bag like I did. You can get a hammer. I'm going to go off screen to the workbench real quick, and you'll hear some banging. I'm just breaking up my ice into smaller pieces. Okay, so that's all I needed the hammer for, and here I'll show you. You can see now I've got smaller pieces of ice because I waxed them with a hammer. Okay, you'll need something to light your candle with, so it says matches, but this is all I have around my house, and then some sandpaper or an emery board. So you don't need much. The only sandpaper we had lying around was stuff that goes on one of my husband's electronic sander things. So I stole one of those for the experiment. Okay. All right. And then what do we want to do before we start our preparation steps? I already have part of it. If you're thinking put your PPE on, you are correct. So let me go ahead and fasten up my PPE. So get my coat all ready to go. All right, and then I want my goggles and a pair of gloves. Okay. And then a couple other things that you'll find useful. If you get an extra one of your plastic cups and you pour some water into that plastic cup, it's actually easier to pour into your graduated cylinder from the plastic cup than it is from a big old jug. So I have some water in my plastic cup. And then you might also find it useful to have one of your spoons to help you scoop chemicals for weighing, and then a pipette, because there's a couple of points where you're going to want to drop stuff in with a pipette. Okay. All right, so the first thing it wants you to do is get everything ready to go. All right, and it wants you to prepare your solutions of colored water. So what you're going to do is you're going to take your graduated cylinder, the 10 ml one, and you're going to measure out 10 mils of water, put that into a test tube, okay, and you'll do that again, add 10 mils to another test tube, and then you'll take your food coloring and you'll put 1 drop of yellow into one of the test tubes and 1 drop of blue into the other test tube. Okay, and that will be your preparation. All right, when you go to weigh stuff, all right, you'll turn your balance on. Okay, and then once your balance is on and you put a weigh boat on there, it will read a number. And then if you hit the tare button there on the right, okay, that'll zero it out. And now you can add to the balance without having to do any subtraction. All right, so let's talk about your various different activities. Now, I'm not going to demo every single one of these activities because I want you to see all of these physical and chemical changes for yourself. I'm just going to go through each activity and give you a few tips about how you should go forward with that particular activity to help make it easier. All right, so your first activity, okay, you're going to be using hydrochloric acid, okay, and some sodium carbonate. And you're going to mix those and you're going to do things like observe what happens and you're going to take the temperature. So your thermometer, okay, hopefully your thermometer came like mine did and has a little thing already around it. In your instructions, it gives you some ideas about something you can wrap around your thermometer to keep it from rolling off your work area. But if it came with this little red triangle or something similar on it, if you put it down, it won't roll, okay? So I'll put my thermometer there and put its case off to the side, okay? And then I don't know if you've noticed in other videos, I have stuff over here in my pencil holder. Okay, this is another thermometer. Well, I keep both my thermometers in my pencil holder standing straight up. If you store your thermometers laying off to the side like this, over time, the alcohol solution in there can separate and it can kind of mess up your ability to use your thermometer. So if you have a chance to store it upright, it's better to store it standing straight up like this, okay? So when you record your temperature, okay, you want to put the thermometer in the test tube and you want to get eye level as much as possible with the thermometer like we've been doing with every other measurement that we make. So that way we get a better view, because if you try to hold it, you'll end up reading it weird because you'll be at a strange angle. Okay, now for my data table, okay, I've got activity 1, 2, 3, etc. So things that it wants me to record: color of initial items, color of final items. Okay, so I'm going to look at the 2 solutions I started with. What color were they each? Okay, so notice that we've got initial items, that's plural. So you need to make sure that you're recording the color of each initial item, not just one of them. Okay, and then color of final items. Now, depending on what you're doing, you may only have one final product to record. Then your initial temp, your final temp. Then observations. Make sure you write down observations. This will help you later identify whether or not it was a physical or a chemical change. Because that's the next box, the type of change. Okay, so in the box where it says type of change, okay, what we were looking for is physical or chemical. Okay, so that's what you have to identify. And then explanation. Okay, it's not enough to just say it's a physical change or a chemical change. Explain why it's a physical change or a chemical change. So you have to give reasons there. Okay, and so for that data table, it's a data table. So in my little pencil cup, I have a pen and I have a pencil. Which one should I use to record my data? You said pen, you were correct. All right. So there's our activity 1. Okay, now when you are done using things like your thermometer, okay, here's why you want the pipette. The 250 ml beaker is going to be your wash basin. So what I'm going to do is I'm going to squeeze my pipette, put it into my water, and drop some of the water. And now I'm going to rinse off my pipette. I'm going to do this 3 times. Okay. In the lab, we have bottles that have arms on them so that you can squirt out of them. We don't have that in our at-home kits, so we have to just use a pipette and rinse off like that. Now, one thing you can do is, if depending on your work area, if it's easier, and I'm going to step off the frame a little bit, I'm going to grab a towel. Okay, I can put a towel down so that as I use things in between, while I'm waiting to use them again, I can lay them on my towel to dry a little bit. Okay. All right, now, if I've used my test tubes, I'm done with activity 1. I'm going to pour them out into my beaker, and then I'm going to do the same sort of a thing. I can try to pour into the test tubes a little bit. Okay, I don't need to fill it all the way up. I just need to put a little bit of water in. I'm going to shake it around. Okay, I'm going to rinse it out, and I'm going to do that 3 times, just with a little bit of water. And then I'm going to shake it out the best I can. All right, and I'm going to put that on my towel. When you're doing these activities, it's okay if your test tubes are not completely dry in between each activity. The most important thing is that you rinse them out with the distilled or deionized water, and then shake them out the best you can. If there's tiny little drops of water left behind, that's okay. The solutions that you're using in this lab are aqueous. Aqueous means they are dissolved in water, all right? And this is a qualitative lab, not a quantitative lab, which means that if the concentration of your solutions is off just a smidge because there's a tiny drop of water left in your test tube, that's okay. All right. There are certain things we're having you weigh out or, use exact amounts of, because we want to make sure that you're using the right proportions of everything. All right. But you are just taking observational data. You're not taking numbers down this time. Okay. All right. Activity 2, you're going to have 2 test tubes. You're going to add some water to one of the test tubes, and then you're going to add 0.3 grams of pre-weighed sodium polyacrylate. So this is where you're going to take that sodium polyacrylate and you're going to turn on your balance, right? You're going to put the weigh boat on your balance. You're going to hit the tare button. Now the 0.3 grams, okay, your balance goes out to 2 decimal places. So it doesn't need to be exactly 0.30. If it says 0.31, you're fine. If it says 0.29, you're fine. Don't spend a ton of time trying to make sure you have exactly 0.30. Okay, in order to use this, what you're going to want to do is probably cut off the corner of it, and you can shake some into your weigh boat. And then when you go put it in your test tube, you will want to pinch the weigh boat like this, pick up your test tube that has the water in it, and then pour like that. And it will make a nice pour spout that your compound will come out of. And then you can set the weigh boat off to the side to be washed. Okay. Now your weigh boats, you will want those to be dry. So that's why we had you pull out multiple weigh boats. So that way you can use a fresh dry one for each activity and then just wash them all when you are done. Okay, let's see here. Okay, and then you'll finish and you'll wash everything out. And then it says to dispose of the product in the trash. Okay, then we've got activity 3 where you'll be using the copper 2 sulfate and the sodium carbonate. Okay, now these dropper bottles, okay, this tells you to use 2 mils of the 0.5 molar copper 2 sulfate. Okay, so I can, from my dropper bottle, squeeze into my graduated cylinder, or for the purposes of this experiment, okay, 20 drops is approximately 1 milliliter. Okay. And I say approximately because depending on the type of drop, sometimes you have a finer drop, sometimes you have a bigger drop, but generally speaking, from bottles like these, 20 drops is approximately 1 mil. And so you can squeeze out 2 mils into here and then pour that out, or you can drop 40 drops from here directly into your test tube. That's up to you which way you want to do it. If you drop the 40 drops directly into your test tube, that's less washing that you'll have to do of your graduated cylinder. So it's up to you which way you want to do it. Okay, and so that'll work for the sodium carbonate bottle and the copper 2 sulfate bottle because they are both dropper bottles. Okay, so that's activity 3. All right, activity 4, you're going to use your tea candle. Right now, your tea candle comes with the wax down. So if you've never lit a brand new candle, what you will want to do is bend up that wick so that it's sticking up. So that way, as you go to light it, okay, it's easier to light. Now there will be wax on your wick, so you will probably have to hold your flame to your tea candle for a couple of moments until it catches. Okay, now we tell you to use matches. In the lab, we make sure you use matches because we have Bunsen burners and we have active gas flowing sometimes. And so we don't want to use these click lighters that have gas in them in the lab. We use our matches. But if you're in your home and all you're doing is lighting a single candle, if you use a click lighter, because that's all you have around your house, it shouldn't be a problem. All right. And so I would hold this. And again, I would have to hold it to my candle for a few moments to get that initial wax to melt off, and then my candle lights. Okay, so let me move some of these bottles over so that you can see, hopefully, that I do indeed have a lit candle here. So I'm going to do my observations for a minute. All right, and then when I'm done, I can blow my candle out. Okay, I'm going to need it again, so I'm just going to set it off to the side. Okay, the next part is telling you to do your ice. Now, if you already have your ice ready to go, you've already smashed it small, you don't need to blow out your candle because this next part uses the ice and uses the candle. Okay, you're going to take a piece of your ice. Okay, you're going to put it in that aluminum dish that you have. And then if you notice, your dish has this little lip on the edge of it. That's so that you can hold it, and you will then hold it over the flame and make some observations about what's happening to that ice as you hold it over the flame. Okay. All right. Okay, and then your aluminum dish you'll use again later in activity 11. Okay, activity 5. Okay, you're going to use some sugar. Now, I told you that I put my stuff into these small containers. You may not have small containers, and that's fine. Okay, so I need to use a gram of sugar. So there's 2 ways that I can mass out my gram of sugar. I can carefully shake some sugar out of my container into my weigh boat, or this is why I recommended getting a spoon out of your kit. You can take the spoon, dip a little bit, pour into the weigh boat. Dip a little bit, pour into the weigh boat. Okay. Again, this says add 1 gram. That's not a whole lot. And it just says 1. It doesn't say 1.00. So if you have 0.9 grams, you should be fine. If you have 1.1 grams, you should be fine. Okay. Don't spend forever trying to get exactly 1.00. Just try to get as close to that 1 gram mark as possible. And again, when you go to do this, you want to pinch your weigh boat, put it into your test tube, and then pour, and it's a nice little funnel, and that will keep stuff from going everywhere. And then I can set my weigh boat off to the side so I can clean it later. Okay. All right, activity 6, you're going to use sodium hydroxide and phenolphthalein. Now, step 5 of activity 6 tells you to use a pipette to add a drop of phenolphthalein. Well, if you notice, your phenolphthalein is in a dropper bottle, so you don't need to use a pipette to drop your phenolphthalein. You can just unscrew the top, and it's a dropper bottle, so you can put it over there, squeeze out your 1 drop, and you don't need to use a pipette for that. Okay, and then it tells you to save a solution for part B. Okay, activity 7, you're going to use a couple different chemicals. Activity 8, you're going to use that blue and yellow water that you made in the preparation step. Activity 9, you've got hydrochloric acid and some magnesium ribbon. So here's where you need your ruler. So you've got a magnesium ribbon. It's going to tell you to cut a 0.5 centimeter length. All right, so I would take my magnesium ribbon and I would make it as flat as possible. And then I would use my ruler and I would get my 5 centimeters, or my 0.5 centimeters, I mean. So I just need a tiny little piece. All right, so it would only be a small little piece. I would cut that off and I'd add that to my hydrochloric acid. Okay. All right, activity 10, you're gonna use some copper 2 sulfate and you're gonna add some table salt to that and do a few things. Activity 11, so this is where you saved some stuff for activity 11. So that aluminum dish that you had earlier, okay? Now we're gonna have you cut up the aluminum dish into pieces and add those pieces to some of the things that you saved from other activities. So it says to add to, what you prepared in activity 10. So one thing when you add metal to these solutions is it's going to tell you to use the sandpaper with the nail, but you can also use the sandpaper with the dish. If you rough up the edges a little bit, if it reacts, it'll react a little bit faster. And so when you rough up the edges, you don't need to sand it and sand it and sand it. You just take the sandpaper and you just do a couple quick brushes, That's all you need. You want to put just a couple little grooves in it. Okay. And then activity 12, you'll be using some copper 2 sulfate and you'll use that nail that was in your kit. All right. So that's kind of the rundown of everything you're doing in this experiment. And one of the key things to remember is you have to use that distilled or deionized water because your tap water has dissolved stuff in it and you're observing reactions. And so you may not get a proper set of results if you are using water from your tap. Okay. And the other thing, make sure you record your data in ink and you are taking good observations. This lab relies on observations. Okay. You can do all the activities and fill out everything up to the observations column. And then once you are all done and completely cleaned up, then you can sit down and you can look at your observations and identify the type of change and give your explanation for why. Okay, it's not a bad idea to just get the experiment done and then sit down and analyze it when it's all done, because you can take all your PPE off. If you try to analyze each, individual activity as you go, you'll have to keep your PPE on the whole time. So it's always nice to finish your experiment and then take your lab goggles off and sit down and analyze it. Okay. All right, so I think that is everything I have to tell you about this experiment. So hopefully you'll enjoy doing this one. It's pretty cool to see all the crazy different reactions that are there and to see stuff, do things. So anyway, I hope you enjoy this experiment, and that is all I have for you this week.